Okay, good morning, students. We'll start the class. All right. So we were discussing about the recommendation system. All right. The previous class we discussed about content-based recommending system, and then we discussed about collaborative recommending system. Then under collaborative, we discussed about user recommending system and item-based recommending system. So in today's class, we are going to check out evaluating the recommender system, whether the recommender system that I have written is doing good. Okay, you want to evaluate it is what we are going to do in today's class, discuss in today's class. Now, when we do such recommendation system, there are two methods of evaluation. Okay, take it any machine learning or deep learning algorithms. There are two types of evaluation techniques. One is online evaluation. The other one is the offline evaluation. Okay, so many times the real online evaluation is best for recommendation system, because you recommend a product to the user, and how the user respond to that recommendation is what you need to collect it and evaluate your algorithm. Suppose you are just recommending in random. Okay, so in that case the customer is not going to get that product, the customer is not going to like that movie, or he's not going to give a good rating for that movie or good rating for that book. Okay, in that case your recommendation fails. All right. So researchers suggest that the real-time evaluation of recommendation system is the best. Okay, however, many times we will not be able to evaluate on real time. Suppose you are writing your own recommendation system. If you run your own business, you can just implement and check it out. But most of us don't do that. Okay, so we have few offline evaluation metrics to do it. Okay, so we will discuss what are those offline evaluation metrics, and also in our today's class we will see how to design a small random based recommendation system. It is not the true recommendation system or content based or collaborative based. We are going to discuss that in the coming classes. Okay, but today's class we will discuss the evaluation metrics, and then we are going to discuss how to design a small recommendation system for a movie. Okay, so movie based recommendation system. So I'll just share the presentation. So evaluating the recommendation system. Okay, evaluating the recommender system. So I told you there are two types, offline and online. So we are going to see about a series of offline evaluation metrics. Okay. So number one is the statistical accuracy metrics. So we have discussed about few statistical metrics in unit 3. If you remember, mean, standard deviation, variation, variance. Okay, so correlation. So here also the mean absolute error, the root mean square error, and the correlation. These are all the well and good known statistical accuracy metrics. Okay, so we'll see few statistical accuracy metrics. Number one is, how do we do this? How do we do an offline metric system or offline evaluation? Is initially we will divide the entire data set. So offline evaluation involves a data set. Okay, you will just test it against a data set. So you will take the data set and you will divide the data set into training and testing. Okay, now what you do is you will run the recommendation system and you will train it with your training set. Okay, maybe you run a support vector machine or any algorithm you have. You will first initially train the recommendation system using your training set. For example, this is how it should be. Okay, you will train it. Then you will test it using your testing. Okay, you will give a few testing patterns, and then you will check out whether your recommendation system is recommending correctly. Okay, so now if it is recommending correctly, then there is no error. If it is recommending wrongly, then it is taken as an error. Okay, so this is how you will evaluate it offline. Okay, you will take a data set, divide it using training. You will train the algorithm. Then using testing, you have to test it. For example, in the training set, you will say if a user likes A, B, C, okay, and if another user like A, B, suggest C for user 2. Okay, you say suggest C for user 2. That is what you will just tell in the training set. Again, in the testing set, what you will do, you will give A, B, C to user. User 2 likes A, B. Now you will test whether C is suggested for user 2. Okay, if C is suggested, no error. If C is not suggested, error, because you have trained the recommender system to suggest C to the user who likes A and B. But if it is not suggesting, then there is an error. Okay. So this is one example with which you will evaluate the recommender system. Okay, now mean absolute error. This is the formula for mean absolute error, 1 by n predicted minus actual. So what is actual? Actual is user 1 has purchased A, B, C. He also has purchased A and B. Okay. But what is predicted? This what is actual? C is suggested for user 2. That is actual. So what is predicted? Predicted is whether C is suggested. If C is suggested, the prediction is 1. If C is not suggested, the prediction is 0. Okay. So prediction versus, so I'm telling for collaborative filtering. The same case for content-based filtering, user-based collaboration and item-based collaboration also. Okay. So mean absolute error was one performance metrics used, 1 by n, summation of predicted minus actual. Then root mean square error is just take a square and a root. Okay, that is what you call as root mean square error for evaluating the recommendation system. So next one is hit ratio. What is that hit rate? Hit rate is first you generate the top recommendation. Okay, you just generate the top recommendation. If a user clicks from that top, okay, if a user suggests from that top recommendation, it means that you won. Okay, your hit is successful. Okay, if he did not if he did not select from that top end, then hit rate is not done. Okay, 0 hit. Okay, so what is hit rate? You take top recommendations. From the top recommendation, if the person selects that, then hit is yes. If the person did not select, hit is 0. Okay, that is what you call as the hit rate. Okay, then you have something called cumulative hit rate. Okay, so what is that cumulative hit rate? So cumulative hit rate is you have a threshold. Okay, you have a threshold for recommendation. Okay, so below the threshold, you omit everything. Okay, you omit all the products below that particular threshold. Now you have below the threshold you have omitted. You have very limited number of recommendation. Okay, you don't have a full recommendation of full content. You have very limited recommendation. So from the limited recommendation, what is the hit rate? That is what you call as a cumulative hit rate. So here you see rank 2. Okay, it has very less predicted rating, so that is removed, and this is also removed. Okay, so only 5 and above is taken. Okay, only 5 and above is taken. This is what you call as a cumulative hit rate. Then there are few more terminologies called coverage. What is coverage? Coverage is the percent of items in the training data the model is able to recommend on the test set. Okay, so that is what I told you. In the training set, A, B, and C is recommended for a person. Again, A, B is recommended. Maybe we'll take another example for content-based filtering. Okay, I take A, B. Okay, there is also the same brand of A1, B1. Okay, so in the training set, I have trained the algorithm that if A, B is selected by the user, you have to suggest A1, B1. Okay, I say if A, B is selected by the user, you have to select A1, B1. So now you just wait. Okay, you just test the algorithm. A, B is selected. Immediately, if A1, B1 is also suggested, then the coverage is full. Okay, the coverage is achieved. Okay, otherwise the coverage is not achieved. Okay, because you have trained the algorithm to suggest it. And if the algorithm suggests that, then the coverage is achieved. Otherwise, the coverage is not achieved. Okay. Then personalization. Personalization is how you test whether the personalized product is recommended for you. Okay. So whether the personalized product is recommended for you. We'll see. Personalization is a great way to assess if a model recommends. Model means your algorithm. Okay. The algorithm that you write. Many of the same item to different user. Okay, many of the same item to different user. Okay, so the same items was it recommended to different users. For example, I like A, the other one also like A, the other one also like A. So people who likes A, let's take 3 users. Okay, user 1, user 2, user 3. Okay, now user 1 likes A, he also likes A. Okay, these two fellows also like B. Okay, now whether this guy likes A and B. Okay, so that is what understanding the experience of the users is what is personalization. Personalization has nothing to do with your data sets and everything, but how personalized the users are is what is the personalization. We'll see with an example. Okay, let's take this example. So now what happened is A, B, C, D is what is, it is predicted that user 1 may like. Okay, A, B, C, D. All of you listen to this example. Okay. So this example says that A, B, C, D is what user 1 likes. Then user 2 likes A, B, C, and X. Okay, user 2 likes A, B, C, and X. Then user 3 likes A, B, C, and Z. Okay. Now I make a user item matrix for 3 users. Okay, this is what you call as user item matrix. These are all the users, these are all the items. Okay, 1, 1, 1, 1, 0, 0. Because user 0 has not purchased X and Z, he is having 0, 0. Then user 1, he has not purchased D and Z, so it is 0, 0 for him. Okay. Then user 2, A, B, C, Z. Okay, so those items has 1 and all the others has 0. Now the question is, the next step is you form the cosine similarity matrix for 3 users. Okay, I'm making, this is what you call as the cosine similarity matrix. We have discussed the formula. Okay, so the formula is there. Using that formula, we discuss the cosine similarity matrix. After we take the cosine similarity matrix, we calculate the average of the upper triangle. Okay, we calculate the average of the upper triangle. So when we calculate the average of the upper triangle, it is 0.75. So 1 minus 0.75 is 0.25. Now personalization for these 3 users is 0.25. So what do you infer from the personalization is a high personalization score indicates user recommendations are different, meaning the model is offering a personalized experience to each other. Okay, so if the personalization is high, it means that many users, every user likes different products. Okay, if the personalization is too high, it means that the users, okay, the users who are coming in likes different products, and the model also recommend to them their own personalized information. Okay, their own personalized information. This is what you can evaluate through personalization. Okay, then what is that you will do with the next one? Intra-list similarity. Okay, intra-list similarity. So intra-list similarity is used to understand how similar users are. Okay, how similar the users are. Okay, whether they are similar or whether they are dissimilar, like that you will be understanding. For example, I have 10 users. So how about the taste of 10 users, whether they are similar or dissimilar, is what you will understand from intra-list similar. So now let's take this user 1 likes movie 3759. Okay, he likes 3759, and user 2 likes 9, 6, 12 and 623. Okay, he likes 9, 6, 12, 623. Then the third user likes 7, 894, 6 and 623. So he likes these movies. Okay, now then the recommendation, these are the different recommendations of movie IDs for 3 different users. So this is what is recommended for user 1, this is recommended for user 2, this is recommended for user 3. Now what is the perspective of user 1 on those movies? Okay, so user 1 is recommended with 3759. So he says that it is a comedy movie, 3 is a comedy movie. And 7 says again it's a comedy, the user 1 says 7 is also a comedy movie. Then 5 is also a comedy movie and 9 is an action movie. Okay, this is what you call as the movie generate features matrix. Okay, this is what you call movie versus the feature matrix. So this is the perspective of user one. All right. Now this is a prediction of that users, and this is the perspective of user. Based on this, how similar did they have they rated the movie? Okay, whether the first person and the second person have they rated the same. So similar matrix has to be formed for everybody. Okay, 9, 6, 12, 6, 23, 7, 8, 94, 6, 6, 23 has to be formed for everybody. Okay. So what is the similarity between them? Everybody says that this is a comedy movie, or somebody else says, no, this is not a comedy movie, it's a romance movie. Okay. So what is that they say about the movie is what you get from intra-list similarity. Okay, intra-list similarity. Then there are a few more called diversity. Okay, so it is a measure of how broad or variety of items our recommender system is putting in front of the people. Okay, how they were able to put different type of recommendations over the people. Then churn. Okay, how often do the recommendation changes? Okay, so if the user rates a new movie, does it substantially change their recommendation? Suppose a user comes now, he rates a movie as 5. Okay, so tomorrow he rates it as 1. So does his recommendation changes? So if the recommendation changes very often, then the churn is high. Okay, the churn is high. Then responsiveness, how quickly does the new user behavior influence the recommendation? Suppose a new user is coming in. Okay, so he gives his own rating for the products, he gives his own rating for the movie. How does it influence the overall recommendation of the recommendation to other users also? So that is what you called as the responsiveness. So now we have discussed so much of evaluation metrics, statistical accuracy, and then we discussed about very general model-based accuracy also, model-based evaluation metrics also. Now, what is that we will select? Okay, we may get confused on what is that we may select. Now, if you are evaluating recommendation centric, if your evaluation is based on whether my recommendation is correct or not, then you go for such evaluation metrics. Correctness, you measure the correctness, coverage, diversity, recommender confidence. Okay, so you measure those metrics. If your evaluation is based on user centric, what is user centric? That is, you are measuring whether the user is correctly prescribed. Okay, whether the user is correctly prescribed, whether both the users likes the same products, like the same movie. In that case, you go for this. Then system centric. Okay, so if you want to test whether your recommendation system is secure. Okay, whether your recommendation system is able to recommend the product to any number of users, like your Amazon, Facebook. Okay, they were able to do recommendation for any number of users who joined them. They have millions of users. Still, those millions of users were given proper recommendation. Okay, in that cases, system centric. You go for system centric measurement. Okay, then delivery centric. Okay, so these are the different suggestions that people make for evaluating. Then, of course, you have to do it precision recall. Okay, the well and good precision. What is precision? What is recall? We discussed this when we are discussing the classification technique. If you remember, we just draw a confusion matrix. Initially, we'll draw confusion matrix. We measure false positive, false negative, true positive, true negative. Then from that, we will measure precision recall F score. Same thing we can do it here also. Okay, we can do a number of our recommendation that are relevant divided by items we recommend. Okay, so then recall is our recommendation that are relevant divided by of all possible relevant items. Okay, so precision and recall is very important. Okay, very important. So then if you want to calculate how your recommendation system works for a single user, whether the recommendation system is good for a single user, in that case you go for mean average precision. Okay, mean average precision, right? So now, so far we have discussed about evaluation of the recommender system. I would like to show you a small recommendation system, that is demographic recommendation system. Okay, I'll type that in the chat box. Okay, demographic recommendation system. What is this demographic recommendation system is? It's a recommendation system which will recommend in random. Okay, it does not check out whether he likes what he likes, whether he likes. Okay, what that person likes, whether this person likes. No, nothing like that. No rules are applied. Just based on the rating, it recommend. Okay, the popular one are recommended to the user. Okay, so it is not user centric. Okay, it is fully data centric. All right, based on what the rating the user has given, it just sort it out and gives you the best one. All right, so how do we do that? We will see. We are taking the data set. Okay, we are taking data set where the first data set has movie ID, cast and crew. Okay, please all of you listen here. We have the first data set has movie ID, cast and crew. The second data set has 20 columns where we have the budget, what is that movie about, action, thriller, comedy, or what is that about, then homepage, ID, keyword, original language, original title, overview, then again popularity. Okay, so production company, production countries, release date, revenue, runtime, status, tagline, title, vote average rating the movie received. This is what is very important for the demographic recommendation. Then vote count. Okay, now what is that we are going to do with it? All right, we are going to do a weighted rating. Okay, so then after doing the weighted rating, we are going to sort it, and whoever comes the first, we are going to recommend for the user. So for the weighted rating, we have selected the formula as V by V plus M into R plus M by V plus M into C. Okay, so what are those parameters? V, M, R. V is number of votes for the movie. Okay, number of votes for the movie. So where do I get the number of votes for the movie? This is here. Okay, vote count. The count of votes received. So already it's there in the data set. So I need not worry about that. Okay. Then M is which qualifies the movie to come inside the calculation. Okay. For example, I'm not going to take, there may be thousands of movie in the database. Okay. I don't check out the rows. Okay. There are thousands of movie in the data set. But now I'm not going to take all those. Only those movie which has 90% of rating, we are going to bring it inside. Okay, so for that, how I am going to do 90% of rating? I'm going to calculate the quartile. We have a parameter called quartile. Okay, so that quartile I'm going to calculate. All right, so 90% of quartile, if it has, then it will come inside the recommendation engine. Only such movies come inside the recommendation engine. So how do we do that? We'll see. Okay. Then R is the average rating of the movie. So where is R? R is here. Okay. Average rating of the movie received is already there in the data set. So I need not worry about R. Okay. Then what about C? C is the mean vote across the whole report. Okay. Whole report, I'm going to take a mean. Okay. That is what is called as the C. All right. So just do it dot mean, it will give you the mean. Okay, vote average dot mean, it's going to give you the mean. So how are we going to do it? We'll see. I'll explain the program now. You can just listen to the program. So import the libraries. All right, import the libraries, and then we are importing the data set. I told you there are two data sets. The first data set has, what are the parameters in the first data set? Movie ID, cast, crew. For a recommendation system, for a demographic recommendation system, which is purely based on rating, the cast and crew is not required. Okay, so maybe many of us like a movie because it is directed by a particular director. But now for a rating based recommendation system, this is not required. So I'm going to remove it. How we do that, we'll see. Okay. Then here, in the second data sets, we have n number of details, which is again not required. Okay, what I need is only ID, then the title, because I have to display the result. Title, then the rating. Okay, we'll see. Okay. So now what do I do is we just import the data set. We'll see how it works. Okay, till here um, yes, it has imported. Okay, it has imported the data. So df1 dot head. We'll do head. So it says that I have 5 rows and yeah, head will display only the 5 rows and 4 columns. There are 4 columns in it. ID, cast, crew, and everything is there. Title, cast, crew. Then let's say what is df2 dot head. Okay, what is df2 dot head? There are 5 rows again because it's a head command. It will display the top five and 20 columns in it. Okay. Now what I'm going to do is I'm just going to merge both into a single data set. Okay, a single data set. So this is what I'm doing here. df1 columns are ID, title, cast, crew, and df2 is you just merge based on ID. Okay, df2 dot merge df1 based on the ID. Okay, so what do we do here? Let's just run these two. I'm running those two commands. And now let's check out what is df2 dot head. Okay, whether df2 initially df2 had 20 columns. Now I have included ID. Based on ID, I am just merging. I have included 3 more columns called title, cast, and crew. Okay, so we'll see how it is done. Yes, now it has 23 columns. Okay, it has 23 columns. Initially, it has 20 columns. After merging, it has 23 columns. Okay. Now, I told you that here is the formula for doing it. Okay, what is the formula? I need V. Okay, number of votes. It's already there in the data set. M. It's a 90% quartile. So, we have to calculate it in the program. Then R, average rating of the movie. It's already there in the data set. Then C is mean. We have to calculate it. Okay. So we are calculating it here, C, the mean. Okay. So function F9 will give you the answer. What is C? Let's just print and check out what is C. It's 6.09. The average, the mean rating of the movie, all the movies is 6.09. Okay. So shall we calculate M? This is a formula for calculating the M. Okay. Dot quartile of 0.9. Okay, so we'll just run this program, this command, and we will do M. So M is 1838. So anything that is below 1838 will not come inside the voting process, will not come inside the evaluation process. Okay, right. Now what is the next step we are going to do is we have to eliminate. Okay, we are going to eliminate anything that is less than 1838. So that is what is going on here. df2.copy.location of anything which is greater than M, you copy it to Q movies. Okay, that is what is the command says. Okay, anything greater than M above 90% is what we are considering here. So anything beyond that 90% you bring it here. So we will see running these two commands. Check out what is the 481 movies have been qualified for recommendation. Okay, so the total may be something very big. Okay, we'll check what is the total. df2.shape. What is df2.shape? It is 4,803 movies. From 4,803 movies, only 481 movies have been selected for recommendation. Okay. Now after that, here is where the function is written for calculate. The formula is written here. You could see V divided by V plus M because we already have V, we already have R, C is calculated, M is calculated. Okay. Now considering everything, we are calculating here in the function. Okay. So the function is applied here. Q movies dot apply of, you calculate the score. Okay. You include new column called score for every movie. Okay. So the score is calculated by applying the function. Axis is equal to 1. We already have discussed in the first unit. When axis is equal to 1, it's based on a column. Okay, a new column is added. Okay, so we'll see how it is done. Okay, now its score is calculated. Okay, the new score is calculated. All right. Now after that, what do we do? Okay, we have calculated the score for every movie. That is 481 movies. The score is calculated. Now we are going to sort it and suggest the top 10 movies for the users. Okay, so shall we sort it? Okay, we will sort it here. We are sorting it here. Okay, ascending is equal to false means we are sorting it. Okay, then after you sort the highest score movie, ascending is equal to false means it will sort it in the descending order. The highest score movie will come in the top. Okay, shall we print it? So we will print the movie's title. So you see here, these are the movies which are suggested, the top 10 movies. Okay, I just do only the 10. Yeah, head of 10. Only the 10 movies are suggested. Then their score. Here is where their score. Okay. Now these are the different movies that is suggested. You can just have a look at it. It is the ID of the movie is 1881. These are the ID of the movie. These are the movies suggested by the recommendation system. This is the score. This is purely random. It is based on only the user average rating. Okay. It's not how many times the user has reviewed the movie, how many times the user has seen the movie. It's not based on the director, nothing. Okay, it's based on the score. Now, there is one more column called popularity. Okay, in the data set, there is one column called popularity. Now we are going to check whether the popularity and our recommendation matters. Okay, popularity means it's more popular. Many people have viewed that movie. Okay, so based on the popularity, whether the suggestion that we have made is correct is what we are going to check it. Okay, we'll say, okay, well, let's stand just a minute. I'll just to give a power supply to my laptop. Okay, fine, it's done. We'll just check it. What is that, Shri plus you have done? You have checked whether your keyboard is working? Okay, fine. We'll come here. Now, right. What is that we are going to do here is we are going to check out whether the popularity and what the recommendation system has suggested is same. So we will, this is how we evaluate. We are going to do it in the bar chart. Okay, we are going to plot it in the bar chart. Based on the popularity, it is going to plot it. So we will check whether the demographic recommendation is same as that of the popularity. Okay, so function F9 plots, we'll go to the plots. Yes. So can we check the first movie, that the popular movie is Minion? Okay, Minions. Yeah. Is it there in our recommendation? It's not there. And Interstellar is there. Okay, it was a second popular movie. Here it has recommended as 1, 2, 3, 4, fifth movie. Okay, so at least one movie was there inside. So the Guardian of the Galaxy, any other movie? No, it is not there. So we see that the demographic recommendation is not that much accurate. Okay, compared to what maybe the content-based collaborative filtering, we will work it in the coming classes like this. I'll just give you the program also. You can just check it out. All right. Now it says that only one movie among the popular movies were recommended based on the rating of the user and based on the formula. Here we have the formula also, right? We have to, what is that gone wrong here? Why it is not working on well? Number one is, it is mainly depend on rating of the user. Okay, only based on rating of the user. Number two is, maybe you have to prune this weighted average rating rating algorithm or rating formula. Okay, use a little bit of higher machine learning technique. Maybe you have to classify the movies and then all these steps. There are many different algorithms. Okay, n nearest algorithm. What all we discussed in the previous supervised learning and unsupervised learning technique, we can even apply for recommendation system. So number one is it's based on only one single parameter. Number two is you have to prune this formula. Okay, you have to prune this algorithm so that you can get a better result. You will get a very nearer result. Okay. So this is about the demographic recommendation system. In the next class, we will discuss about the content-based filtering technique, how the content-based filtering technique is done. Okay.